Okay, students, now let's come to solve these systems of equation. So in order to solve this system of equations, we can proceed in the following way. So dx over dt equals 4x minus y is given. So we just apply extra derivative on this function. So d by dt of this x over dt, which actually is again d by dt of 4x minus y. I simply used the derivative with respect to t for both sides. And this will be the second derivative with respect to x, with respect to t, as you see. And 4 can be taken out for dx over dt minus dy over dt. So our intention here is to express everything in terms of x, but we are having here dy over dt, but we knew that dy over dt is 2x plus y from the second equation, so we can put 2x plus y here, and minus 2x minus y can come. And still we are having y, so in order to avoid this y, you see, we can take minus y to be, look, this is negative y, so negative y is dx over dt minus 4x. So we can have here dx over dt minus 4x, so that everything can be given in terms of x. So as you see, look, in place of this minus y, we are having 4x minus dx over dt. The rest are as they are. So simplifying this, we can obtain the second order homogeneous differential equations with constant coefficients. So let's find now the solution of this using characteristic equation approach. So this is the auxiliary equation for this dE. So m squared minus 5m plus 6 equals 0. So the factors are m minus 3 and m minus 2. So from this, the values of m can be obtained as 3 and 2. So the general solution, the general homogeneous solution, is going to be C1 is a part of 3t, C2 is a part of 2t, and that's going to be considered as x of t. So x is now determined. Now we need to determine what y is. And you need to know that solving the system of equation means knowing the values of x and y, the dependent variables in terms of t. So we now have determined what x is. So we need to substitute the obtained expression in the first one. You don't need to substitute in the second, because it might be complicated, because this is having two y's here, but in the case of the first one we only have one y, so we better use the first one. So what comes next is the following. We knew that y is 4x minus dx over dt, and this is y equals 4x minus, we know what x is, it is this one. Basically, I can also put this here in x. It is already done here. Y of t is 4 times your x is this one, the obtained expression, minus the derivative of x with respect to the derivative of this one, which actually is minus 3. C1 is a power of 3t minus 2 times C2 is a power of 2t. So simplifying this, y of t comes C1 is a power of 3t plus 2 times C2 is a power of 2t, because this comes, simplifying this, 4 times C1 minus 3 C1 makes 1 C1, and here 4 times C2 is a power of 2t minus 2 times C2 is a power of 2t makes 2 times C2 is a power of 2t. So this comes. So we knew what x of t is from the previous one, and we have determined y of t, so the system is now solved. Proceeding to the next one, we have another system of equations here, students. So you are given dx by dt to be this, and again dy by dt to be 3x plus y minus 5t minus 2. So we just repeat the procedure we did before. So we have to have derivative here with respect to t, just apply derivative with respect to t here, again the derivative with respect to t here. So this is going to be the second derivative, as you see, and here dx over dt, 2 can be taken out, and 2 dy over dt, and the derivative of t is 1, as you see. The derivative of minus 1 is 0. So we are having now d squared x dt squared is equal to dx over dt. But we knew what dy over dt is. Dy over dt is 3x plus 2y minus 5t minus 2. You simply take this and put it here and multiply by 2. And then plus 1 comes because of this one. So after simplifying this, you will obtain this to be dx over dt plus 6x plus 4y minus 10t minus 4 plus 1, which actually is minus 3. Still we are having y here. So in order to avoid this y, we can again consider this one, students. If you multiply this by 2, you can have 4y, and taking 4y to the right and taking the others to the left, we can know what 4y is, and that has been done here. Look, this is 4y. 4y this. It's directly taken from this expression. We multiply this by 2, and we got 4y to be like this, so we simply take 4y, this expression, in place of 4y here, so everything goes to be like this. So as can be shown here, everything is written in terms of x and in terms of t. So finally we will obtain a second order differential equation with constant coefficient but non-homogeneous, like this. And in order to now evaluate, in order to find the answer for this, we need to obtain the homogeneous and the particular solution for x. So clearly the homogeneous can be obtained by using m squared minus 3m minus 4 equals 0, and this is directly obtained by using a factorization approach, and this is m minus 4m plus 1 0, and we do have two solutions for this, m4 and m minus 1. So x of t is c1 is a power of 40 and c2 is a power of minus t. This is actually the homogeneous one, but we need to determine the particular solution for this. So to find the particular solution, we have to consider a linear expression at plus b, because here, as you see, the right expression is as you see minus 12t minus 1. So it has to be linear, students. So that's why I took at plus b to be the linear one. So when you derive this, it will be a, and the second derivative goes 0. So we need to substitute this here. As can be shown, look, the second derivative is already 0. Minus 3 times a minus 4 times x at plus b equals minus 12t minus 1. So from this we can determine the value of a and b clearly. A comes 3 because negative 2, here negative 12t, look, negative 4 times a is negative 4a, this has to match with negative 12. And a comes 3, and here the constant minus 3a minus 4b must match with minus 1, and since a is already determined, this will be minus 9, so bringing this to the right, 8. So minus 4b equals 8 means b is minus 2. So the x particular is now obtained, 3t minus 2, because a is 3 and b is minus 2, so 3t minus 2. Thus, the x of t is now can be determined as the homogeneous solution, the one we obtained, plus the particular 3t minus 2. So x of t is now determined. So in order to determine what y of t is, just use substitution technique. And we knew that dx by dt is given by this one in the first equation, in the first system of equations. So your y of t from this directly is 1 over 2 dx over dt minus x minus t plus 1. So here clearly, students, we can take the derivative of the obtained x expression with respect to t minus your x directly here. So your yt can easily be obtained in such a way. So your y of t is 1 over 2, this is the 1 over 2, d by dt of the x expression. So the x expression comes as it is, as you see, minus the x expression is written again, and minus t plus 1. So simplifying this, we can obtain y of t to be as you see. You can obtain this one, just take the derivative of each of these, and you will obtain that to be here as can be shown, and these expressions are written as they are. So simplifying like terms to simplifying this expression or collecting like terms together, one can get y of t to be this one. Y of t is half of 3 times c1 is a power of 40 minus 2 times c2 is a power of minus t minus 40 plus 6. Thus, students, y of t is finally this one. We just multiply the entire expression by 1 over 2. So y of t looks like this. And we knew what x of t is, and we have also determined what y of t is. So clearly we were solving the system of equations. Solving the system of equation means finding the unknowns x and y. X and y are our dependent variables which depend on the independent variable t. Now as you see, x of t is determined, c1 is a power of 40 plus c2 is a power of minus t, the homogeneous one. plus the particular one 3t minus 2. So these entire expressions represent x of t, and your y of t is also determined as 3 times c1 over 2 is a power of 4t minus c2 is a power of minus t minus 2t plus 3. So the system of equation is solved.